in ionic bonding, there are three categories that we will discuss. The first category of ionic bonding is what I like to call simple cations and anions. And what I mean when I say simple cations and anions is the one that come from the main group elements. So to illustrate this point, let's take a look at sodium and chlorine combining together in an ionic fashion. When sodium gives away its electron to chlorine, sodium becomes a positive ion, and when chlorine receives that electrons from sodium, chlorine becomes a negative ion. Now that we have a positive charge and a negative charge, what do we know about the attraction between a positive and a negative charge? Right? They are very strongly attracted to each other. This attraction is what we call an ionic bond. And this bonding occurs in a 1-to-1 ratio. For every 1 sodium, there is 1 chloride. The reason for this is charge balance. Most things in nature will be electrically neutral. So in order for the substance to be electrically neutral, the charge of the positive and the charge of the negative must be equal to each other to cancel each other out. So mathematically, we can see that the sodium is positive 1 and the chloride ion is negative 1. So positive 1 plus negative 1 is equal to 0. To annotate that when sodium and chlorine come together in a 1-to-1 fashion, we use subscripts. We can write sodium subscript 1, chloride subscript 1. But remember that whenever there's just a 1 in a subscript or a superscript, we kind of ignore it. So we can simply write this as NaCl without the subscript, and everyone would understand that this ratio is 1-to-1. The 1 is understood to be there. So if I give you a combination of any two elements, you should be able to write its formula. So how do we do this? So for example, if I say I have a compound and this compound is composed of chlorine atoms and calcium atoms, can you write me the ionic compound? The first thing you want to do is identify each as a metal or a nonmetal. In this case, the metal is calcium and the nonmetal is chlorine. Remember that ionic compounds can only occur between a metal and a nonmetal, because a metal will give its electron away, becoming a cation, and a nonmetal will gain those electrons and become an anion. A positive and negative are attracted to each other, and that attraction is called ionic bond. So for example, if I am tricky and I tell you what is the ionic compound that forms between calcium and sodium, what would you say? You should be able to recognize that calcium and sodium are both metals, so they would not form an ionic compound. Or if I tell you what is the ionic compound from chlorine and oxygen, you should also be able to recognize that chlorine and oxygen are both nonmetals, so they do not form ionic compounds. In fact, they do form bonds, but not ionic bonds, and we'll talk about that in the next lecture. And so the key again is to find the metal and the nonmetal. Next, you want to ask yourself how many number of valence electrons does each atom have. And remember, the valence electron count just comes from the group number. So calcium is in group number 2, so it has 2 valence electrons, whereas chlorine is in group number 7, so it has 7 valence electrons. Next, how many electrons must be lost or gained for each to have an octet? So calcium has 2 valence electrons, so it should lose 2 electrons, whereas chlorine has 7 electrons, is a nonmetal, so it's going to gain 1 electron. So from this last information, can you write the symbol for the ions? So if a calcium loses 2 electrons, it's going to be calcium 2+. If chlorine gains 1 electron, it's going to be chlorine minus. And the last step is to consider the ratio of the two ions that will result in a net charge of 0. So from our last step, we have decided that we have a calcium 2+ and a chloride -1. So that calcium has a 2+ charge, so you would need 2 chloride ions because each of those chloride ions is only 1. So if you have 2, you have a net charge of -2. And -2 plus +2 will give you 0. From that, you can write the ionic compound formula as CaCl2. Now there is another trick to writing this a little bit more quickly, and that trick is to take the charge of the cation and make the positive number as a subscript of the anion, and then vice versa. So what do I mean by this? So again, we know that calcium is 2+ and chloride is -1. So you take that charge of 2 and put it as simply as a subscript of chloride, and if you take that -1 and put it as a subscript for calcium, you should get Ca1 and Cl2. Again, getting rid of that 1 we come to our same conclusion that the formula is CaCl2. So this trick will work most of the time. Where it doesn't work is when you have a ratio that is not its most reduced form. In our last example of CaCl2, it's a ratio of 1 to 2 that is the most reduced ratio possible. As opposed to this next example, if you have an ionic compound composed of calcium 2 plus and oxygen 2 minus, you might be tempted to put that 2 plus down to the oxygen side and that 2 minus down to the calcium side, giving you Ca2O2. So here the ratio is 2 to 2, but notice that this is not its most reduced form because 2 to 2 is the same as 1 to 1. So you can write it as CaO, and this is called its formula unit. And the reason why we use the formula unit is that you can imagine that you can write a ratio of 1 to 1 in many ways. You can write it as Ca3O3, Ca4O4. You see that it's a 1 to 1 ratio. And it turns out the actual compound is a lot more than one atom to one atom. It could be a billion calcium atom to a billion oxygen atom, right? So to simplify things, we want to be able to write it in its simplest ratio. So let's have a checkpoint. Can you write the correct formula for the ionic compounds that result from magnesium and nitrogen? All right, pause and work on this. All right, so hopefully you recognize that magnesium will be a positive 2 cation and nitrogen will be a negative 3 anion. So in order for them to be charge neutral, they will have a ratio of 3 to 2. So you would write it as Mg3 and 2. And you can always check your formula by doing the charge balance. In this case, we said the ratio between magnesium and nitrogen is 3 to 2. That means that we'll have 3 magnesium 2 pluses for every 2 nitrogen 3 minuses. Mathematically, that means it's 3 times a positive 2 plus 2 times the negative 3. And if that equals 0, then we are charge balanced. Right? 3 times 2 is 6, and 2 times negative 3 is negative 6. So positive 6, negative 6 does equal to 0. That means that we have the right ratio. And 3 to 2 is the most reduced form, so that must be correct also. Now let's talk about naming, and we will take the compound form from calcium and chlorine as our example. The first step in naming the ionic compound is to first name its cation, which is the metal. In this case, which one is our metal? It's the calcium. The next step is to take the base name of the anion. In this case, what's our anion? Chlorine, right? For chlorine, the base name is chlor. You just basically get rid of the last ending, the last syllable. Lastly, you replace that last syllable with an IDE, ide, so chlorine becomes chloride. So the name for this compound is calcium chloride. Let's do another example. What about calcium and oxygen together? Your metal there is calcium, your nonmetal is oxygen. The base name of oxygen is ox, so the name of this compound is calcium oxide. What about lithium and nitrogen? Lithium is your metal. Metals will always go first, both in the formula and in the name. So that's going to be lithium nitride. And again, this kind of naming will only work if you have main group metals. So let's take a look when it is not a main group element. So for example, naively, we can say that this element is called cobalt chloride because the metal there is cobalt. The anion there is chloride. Well, it turns out in nature, this compound also exists. Instead of 2 chlorides, there's 3 chlorides. Would you also call this cobalt chloride then? Now to contrast this, we can take a look at a compound like this, MgCl2 versus MgCl3. Now we know for sure that MgCl3 does not exist because the charge of magnesium we know is always going to be positive 2. So because that charge is positive 2, it always only need 2 more chlorides because each chloride is negative 1. So when we say magnesium chloride, we always will mean MgCl2. On the other side, when we say cobalt chloride, we could mean CoCl2 or CoCl3. Reason for that is because cobalt is a transition metal. It turns out transition metals, when they lose electrons to become a cation, they can lose it in many ways. If they lose only 1 electron, they will be a positive 1. If they lose 2 electrons, they will have a positive 2. If they lose 3, 4, 5 electrons, it will be positive 3, positive 4, positive 5, respectively. So if you have a transition metal as your cation, it becomes a little bit more complicated and you have to apply a different set of rules. We can't use the rules that we just talked about.